Here's how to do friction in physics. So a lot of times you'll be given an object sitting on a rough surface and asked to find what the acceleration and force of friction is when another force is applied. The first step is to draw a free body diagram and label all the forces on our object. There's gravity, which always points straight down and is equal to the mass times 9.8. The normal force, which points perpendicular to the surface and balances out gravity. The pushing force of 40 newtons to the right, and the force of friction, Fs, which always points opposite to where the object is trying to go. The next step you want to do is calculate the maximum static friction, or Fs max. We can determine Fs max by multiplying the coefficient of static friction, μs, by the normal force, Fn, which gives us 59 newtons. Since the 40 newtons being pushed on the block is less than the maximum static friction of 59, this means that the block stays stuck, and so the acceleration is 0. Now, when calculating the force of friction, it's a common mistake for students to say that it must be 59 newtons, since this is Fs max. This is wrong, because if we added up the forces in the x direction, we would then have a net force of negative 19 newtons, which by F equals ma would mean that our block is accelerating to the left, and not stuck. It turns out that static friction is a smart force, which means it only applies as much as it needs, in whatever direction it needs, to keep the object still. In this case, static friction only needs to act with 40 newtons to the left to balance out the pushing force of 40 newtons to the right and keep the block still. So the force of friction is 40 newtons. Now let's see what happens when we double the pushing force to 80 newtons. In this case, the pushing force of 80 newtons is greater than the maximum static friction of 59 newtons we calculated before. So we know that our block will break free and start moving. In this case, what we need to do is switch to calculating kinetic friction, which is the same equation as before, but uses the kinetic coefficient of friction, μk. So following the formula, we calculate our kinetic friction to be equal to 29 newtons, which we can add to our force diagram to now solve for the acceleration of the block. Using the sum of forces is equal to the mass times acceleration, we get 51 over 10, or 5.1 meters per second squared. And there you have it. That's how to solve for friction in physics.